we are now going to shift topics and talk about non-parametric tests. And the question you should ask is, well, what the heck is a parametric test? Parametric tests are all the stuff we've been talking about the whole time. Parameters, those Greek letters, those are the numbers that describe the population, right? What is going on in the population. And we made all sorts of hypotheses about these, from a one-sample t-test to a two-sample t-test to regression slopes and all sorts of stuff. And when we talk about parameters, we talk about, we make assumptions, and parameters have distributions, and a normal distribution. For talking about a mean, we think about standard deviation, so on. But we're going to shift now and talk about non-parametric tests. And these are not going to make any assumptions about the underlying distributions. So you'll see the term distribution free as well. The non-parametric tests are interesting because they allow us to perhaps, maybe, analyze data that we otherwise couldn't do because the parameters like means and other summaries don't work. What would examples of that be? Well, you might think that if you have an outcome that is some sort of rank or some sort of score, the mean might not make any sense. Ranking, class rank, if you're a 1 and a 2 and a 3, what is the average of those? Well, the difference between 1 and 2 might not be the same as the difference between 2 and 3. The rank is sort of an artificially sort of number. We might have things that are measured numerically that aren't actual numbers. We might have things that don't really take a full normal distribution. We might have things that, again, how much does this hurt on a scale of 0 to 10? What is mean pain? It might not make sense. Going from a 0 to a 1 might be a much different thing than going from a 6 to a 7. So this slide says when you would consider non-parametric tests. There's no right or wrong answer. Sometimes you might have to do one of these because the other tests don't work. And that comes from experience and from practice. We might also have to use a non-parametric test if we have the data collected in a way such that there's some weird cap. You ever seen a survey where it's like, hey, what is your income between 1,000 and 2,000, between 2,000 and 3,000, blah, 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 over 50,000. Well, that over 50,000 is going to capture a lot of different people. And we have this nice sort of ordinal thing that kind of makes sense until we get to that value. What number do we put in there? I don't know. You start to think about, you know what, the median might be a better number to summarize the central tendency. And that might be an idea when we go to the non-parametric test. That also leads into the idea, if you can't get your data normal enough so that the mean makes sense and works, you might consider a non-parametric test. There's a lot of these, and you'll use a lot of non-parametric tests. If you go to Google and turn on safe search, I guess, and say, what is the, and you see you get that little autocomplete. If you say, what is the non-parametric analog to, and then just put in the name of a statistical test, and you'll see that some statistician somewhere said, oh, I have some data and the t-test isn't working. Let me try to come up with some other way to quantify this that we can all agree upon as a decent way to look for statistical significance. And those people will see some of these guys, Wilcox and Spearman, Kruskal, Walsh, Friedman, will see how these work. They're basically analogs or alternative or modified versions of the tests you already know, but they're going to have a little bit of limitation because we're going to have to throw away some stuff. But they're going to have some advantages in that we're going to be able to analyze data that otherwise we would have had to say, I don't know how to analyze that stuff. When we look at these non-parametric tests, the hypothesis testing game changes a little bit because there's non-parametric. There's no parameter. The null hypothesis is the average person has 99 problems. These become a little more vague. The null hypothesis is usually that there's no relationship, and then the alternative will be, yes, there is a relationship. And we're going to see this is going to limit us. We talk about magnitude and directionality. We might not be able to make statements about magnitude anymore. We'll show the mechanics of some of these tests, one designed by this man, Frank Wilcox, in the next set of slides.